Thank you so much, everyone, for joining us to the first day of CHEM, our Canadian Higher Education Mission. This day we have Professor Humberto de Guise. He's professor of mathematics and physics at Lakehead University, and Pierre Esbert. They both are joining to provide us with information about the university, about the programs. Thank you so much, Dr. de Guise and Pierre Esbert, for joining us as well. The session is being recorded, so after the meeting you will be receiving the information. At the bottom of the screen you will find a Q&A button or the chat button, so you can ask any question or put any comment there. So thank you for joining us again. Pierre, I give you the floor.
Thank you very much, and hi everyone. So today I'm going to, well, first of all, I'm Pierre Sved. I usually work in Mexico, but now because of the COVID, I'm in Montreal for a few weeks in Canada. And but I've been living in Mexico for 30 years, and Mexico is a place that Lakehead University is close to. So I will start off by presenting our distinguished guest today, Dr. Hubert de Guise. After that, I'll proceed to give general information about Lakehead University, and then Dr. de Guise will do his presentation on one of our many programs, nuclear physics and mathematics at the University of Lakehead. So you get a sense of, from a teacher, from a researcher, what we do at Lakehead. So Dr. de Guise has a PhD in mathematical nuclear physics from the University of Toronto. He did a postdoc at the Centre de Recherche Mathématique at the Université de Montréal. He did an 8-month appointment at Faculté Saint-Jean of the University of Alberta, and he was appointed at Lakehead University in July 2001 as a professor researcher. His research focus is on applications of symmetry methods in physics. He also is a frequent visitor to Mexico, so hopefully you'll have many questions for him. He goes to Guadalajara, to the University of Guadalajara, where he has research projects. He's also has been at the National Institute of Astrophysics, Optics, and Electronics in Puebla, and at the Physical Science Institute in Cuernavaca. He is also adjunct professors in physics and astronomy at the University of Calgary. So I will share my screen now if you can give me permission, Roberto, because it doesn't give me permission to share my screen.
Sure, Pierre, I'm on it.
Okay, so let me know when I can share my screen. I can start talking in general.
You should be able to share.
I'm able to now? Okay. Hold on a second. No, it says you cannot share your screen while the other participant is sharing.
Oh, okay. Okay, now you can. I stopped sharing.
Okay, thank you.
Thank you.
So here you have a picture of international students at Mount McKay in Thunder Bay from our Lakehead campus. You have Lake Superior in the background. We have 2 campuses for Lakehead University. One is in Thunder Bay, the main one. That's where the mathematics and physics program is located as well. We're also in a region where we have a strong indigenous First Nation presence. As you will see there, Lakehead University, it's written in Anishinaabe in the bottom, which is one of the main languages from our region. We have at Lakehead, between our two campuses, 8,500 students. It varies from year to year. 1,800 are international students that come from over 60 countries. We'd like to get more students from Mexico. We've received several students from Mexico, mostly in English training, but I understand in Baja California, your level of English is quite high, so you could come in and do an undergraduate program and also a graduate program with us. We have over 86 such programs between undergraduate, licenciatura, and graduate, maestría y doctorado. So here's the map of Canada. We have 10 provinces and 3 territories, and we're located in the province of Ontario. And here are our 2 campuses. Ontario has 22 universities. It's one of the biggest provinces in Canada, the biggest by population. And also it's located in the center. In Thunder Bay, we like to say it's at the heart of Canada because of our location on Lake Superior, the largest freshwater lake in the world. And north of Thunder Bay, you have a boreal forest the size of France. We're also very close to the United States, about 40 minutes to the border with Minnesota. So typically you would arrive in Toronto from Mexico, and then you could connect on one of the 15 flights daily from Toronto to Thunder Bay. And if you're going to Aurelia, we have mostly undergraduate programs at Aurelia, and it's only about an hour from the Toronto airport. Here you have our campus in Thunder Bay, some photographs. As you can see, it's a modern campus. It has everything on the campus, including residences, cafeteria, laboratories, and gymnasium for students. I'll show you some photos of our Aurelia campus, even though there are no, the program that Dr. De Guise will speak is not in Aurelia. It's also a very good opportunity for other programs such as criminology, business, if you want to be closer to Toronto. I won't go into all the programs that we have because my colleague Hector Michelana will speak about that later today, and he'll give a presentation, a detailed presentation on our several programs and take you through on our residences and everything. So now I'll give the floor to Dr. De Guise, who will speak to us about physics at Lakehead University.
Muchas gracias, Pierre. Disculpad, pero solo hablo poquitito español. So I think even though I go to Mexico regularly, I can follow reasonably well, but to speak it's too much of a struggle. So it's much better if I continue in English. So I hope you will forgive me for that. So I have a bit of a chance to actually discuss the physics program at Lakehead. So as Pierre mentioned, this one is in Thunder Bay. It's a small program. You can see we have six full-time faculty members: Ala Resnick, Mark Gallagher, Api Linananta, Gautam Das, and myself. We are on the Thunder Bay campus. And in Aurelia, we have a colleague, Dr. Chris Murray, who works out of there. In addition to these regular faculty members, we also have a certain number of adjunct professors. So these are professors that are not regular employees of the university. They have a job elsewhere, but they will come in with their expertise to broaden the scope or to help the students on various aspects. So, for instance, one of our adjuncts is Dr. Peter McGee, who is the head of cancer care of the cancer care clinic, of the radiation side of the cancer care clinic at the regional hospital here. So he's a medical physicist by training. We also have Pat Rapley, for instance, who's also a medical physicist. We have an adjunct professor that is from the University of Saskatchewan that works with Ala Resnick on detector physics with applications to the medical sciences. So things to improve essentially the imaging of medical devices, for instance. And we also have a gaggle of adjunct professors that are internal to the university. So there's one from chemistry, for instance, and there's also one from mathematics. I'm not going to talk much about the adjuncts, and I'm going to talk mostly about our own program and sort of the stuff that we do. So you will see on the next slide, the backbone of the department, of the teaching side of the department, is the HBSc in physics, so Honors Bachelors of Science in Physics. So this is the full 4-year degree. It offers a reasonably good mix of experimental and theoretical courses. And of course, it is for those who are really have a deeper interest in physics. You can see from the pictures here on the bottom right of the picture, there's an optical table. This is in a 4-year lab, 4-year optics lab, and it's a hologram setup. If you learn of holography and 3-dimensional imaging, it's basically allows you to take a 3-dimensional image of an object. And the picture on the top, you can see there's something that looks like a kind of a pinkish red color. So this is actually a hologram. So the picture is taken through a holographic plate. So it is a hologram of a cow, and you can see the cow it's on the optics table to the right of that pinkish stuff there. This is an experiment that is done by the 4th-year students. So you can see it's actually kind of pretty cool to be able to do a hologram in this particular way. In addition to the HBSc degree in physics, the Department of Physics also offers a variety of other affiliated degrees. So for instance, we have an HBSc in mathematical physics. This one you trade, you trade some experimental courses with some math courses, but there's still a skeleton of common courses with the regular degree in physics. We also have very popular a degree that is a HBSc with concentration in biomedical physics. So it is quite popular for those people who really like physics, but also like to see the more practical aspect to, say, the medical science. So my colleague Ala Resnick is particularly involved in this. Again, detector physics being one of the strong suits, medical imaging, and this kind of stuff there. We also have, for instance, HBSc concurrent with a bachelor degree of education. So if you're interested in becoming like a high school teacher or something like this, this is the one you would take. And there's also a variety of mix and match here. There's BSc degrees without the honors, with education, and like a number of those things, which will give you like a solid basic foundation in physics, but with possibly a concentration a little in some other area if you wish to continue elsewhere. Our department is small, but so we have 6, but a large department at Lakehead is 12 or 14. So this is not like large department at much larger universities where you can have 50, 60 faculty members. So Even our large department are small compared to others, and physics is actually it's smaller than most. Nevertheless, it's quite enjoyable. So one of the advantages of being a smaller unit is you have small classes. So that in first year, there's a lot of common courses, but once you reach the physics specialist courses in year 2 and 3 and 4, it is not, you will rarely have classes more than 10, 12, 15 students at the most. It's quite rare. So 10 to 12 is a reasonable number. That's a very nice number because it means you actually can make friends quite easily. You basically see a core number of students, maybe 8 to 10 students in the class all the time, so you rapidly get to know who they are. It's also very nice because professors don't have to deal with 300, 400, 500 students. So it's quite easy for students to get to know their professors maybe a little more, a little less formally. They get a chance to talk to them much more than if you were in a larger unit. And for me as a professor and as a researcher, it's also quite nice because I'm not the only one, but the fact that we're a small university and that we have small classes and smaller programs means that we depend a lot more on undergraduate students to help with our research. So it is absolutely not uncommon for the upper year physics students to find summer internships in various research labs, especially those that have an inclination towards exploring the research side of this business. So it's quite interesting. The students get to play with real research grade toys and instruments and that sort of stuff. All right, so why? Well, so kind of a big, maybe a broader question. So why would you want to do physics? So here there was a survey done. This is from 2016 by the American Institute of Physics. And you can see that as a career, it is actually rewarding financially, even if you only have a bachelor's degree. On that chart there, there's quite a range and it's quite variable, but nevertheless, you can see that essentially there are two disciplines that are above physics. One of them is aerospace engineering, and I can't tell you much more about that. And the one above is computer science. And what is very, very nice, for instance, is that there is now a merging of computer science and physics into something called quantum information or quantum computing. So maybe you have heard of the quantum computer. So it's on the next page. IBM has one. You can see it on the left, and on the right is just a picture to give you a sense of the size of what this device looks like. It's very shiny and very golden. Google has one as well. And a number of companies are starting to develop their own quantum computers. And the reason I bring it up is because, of course, for myself and for the department, it's very interesting to see that we have some of our graduates that now work for a company in Toronto that is on the verge of launching their own quantum computer. It's completely it's optical based. So we have two students that completed their undergraduate degree at Lakehead that are now employees at this company. This is a nice merging of physics and computer science. So maybe you also heard about quantum teleportation, and there's stuff like quantum money, and so lots of applications of physics, or at least quantum physics, to extremely right now booming tech sector. And this is in addition to the more traditional outlook like medical physics and stuff of this type here. So I have a chance to tell you maybe a little bit about what I do myself. Pierre mentioned that I work on symmetries of quantum system. There's a series here of pictures. So they go clockwise. So the one in the center is figure 1, and then it goes to bottom right, then top right, and then back to center, and then the top. So this is work that was done with a student. We were speaking of students and their research opportunities. So this is work that was done with a student on illustrating squeezing in spin systems. So of course, I don't have time to give you the technical details, but you can see it comes out quite nicely. And again, the person that did the hardcore work here of coming up with the program to actually produce this was an undergraduate student, Ryan, who has continued later. Another thing that I work on are symmetries in quantum interferometry. So you can see on the top left, there's a kind of cartoon version of what is an interferometer. So it's a device. You send light at one end, and you're trying to work out how much light comes out at the other end. On the left side at the bottom, you see here what happens when you shoot a laser through this sort of thing. You can see the way in which the light propagates with various intensity in the different branches of the interferometer. And my job in this project was to actually come up with the landscape that is on the center of the slide here. You can see it's a landscape that has very nice geometrical features. There's a very nice ridge that goes diagonally across. There's some valleys that also are symmetrically placed. There's some plateaus and whatnot. So my job in this experiment, which was done in Vienna, was to actually come up with the theoretical landscape. And you can see the pins have been placed where these people in Vienna actually took data points, and data worked well with experiments, as you can see from from things on the right. So I do a lot of my work, in fact, with Mexicans. Pierre mentioned that I go to Guadalajara on a regular basis. I have a good friend of mine, Andrei Klimov, that is a professor there. And Andre has, over the years, he has sent some of his students to visit Thunder Bay, and I've also hosted other students as well. So on the right of that slide, you see two amigos. The gentleman on the left, Ruben Arellano Cordoba, was a student of Andre. He was working on a generally similar topic as these pictures of the spin squeezing pictures. And the gentleman on the right, David Amaro Alcala, has just completed his degree at UNAM and has now moved at the PhD level at the University of Calgary. And that picture was taken at the Thunder Bay Lookout, so it kind of gives you a sense of the kind of landscape we're in right now. So this is as much time as I have. Now, of course, if you have questions or something like this, I will be perfectly happy to do my best to answer them. So, gracias.
Thank you, Dr. De Guise. It was very valuable information, I'm pretty sure. A nuestros estudiantes, muchas gracias. Si alguien quiere hacer alguna pregunta al doctor De Guise acerca de la materia en específico, por ahí ya vi un par de preguntas acerca de los programas, entonces ahorita vamos a pasar a esas. Pero ¿alguien tiene alguna pregunta para el doctor? No, not right now. No questions for Dr. De Guise now? All right. No, not yet. I think this question would be for Pierre. We have Fernanda asking about the programs related to arts. What kind of options would you have at Lakehead University?
Thank you. Well, We have a visual arts program available at Lakehead University. I'll stop sharing right now. So that's a 4-year program, and you know, it's related to painting, sculpture, ceramics, dibujo. So I don't know what, Fernanda, what you're looking for, but that's definitely a possibility, a visual arts program at Lakehead.
And Pierre, if I may add, I believe there's a Canada Research Chair in Visual Arts as well that that has been endowed to Lakehead University.
Normally these programs I can get, if you're interested, I can get you an interview with perhaps the dean. It's important that they'll want you to see your portfolio of art as well. So you have on my screen, I'll put it again, but you can see my contact information. So oops.
Thank you, Pierre. Pierre nos va a dejar su información de contacto para que podamos también acercarnos a él, quien es también experto en los programas de Lakehead University. Entonces, ahorita se los vamos a dejar también en el chat. Es el contacto de Pierre Esvedes Mexico Office at lakeheadu.ca, por si quieren acercarse a él o acercarse directamente a Team of Education para que nosotros los podamos poner en contacto. She says that she's not pretty sure which one would be better for her. Bueno, justo nos podemos poner en contacto contigo, Fernanda, para platicar un poquito más, que Pierre también nos pueda platicar más específicamente acerca de esas opciones. And
we can organize a meeting apart, just not for specifics on one individual that's interested in the visual art programs and go into details.
Thank you, Pierre. I would like to thank Dr. De Gies for the presentation. It was very, very interesting for the team and for the students, I think. And thank you very much for joining, Dr. De Gies. So we all hope that you have a great day and a great 2021.
Hasta luego.
Hasta luego. Muchas gracias. And Pierre, thank you. También muchísimas gracias por haber participado en CHEM este 2021. Agradecemos mucho que te hayas unido y bueno, para nuestros participantes, no sé si quieres agregar algo más, Pierre.
No, yo creo que con esto, como les mencioné, a las 5 hora de México, mi compañero Héctor Michelana va a dar más información. Entonces tenemos información sobre becas, sobre residencias, sobre precios y todo eso. Ahora era más para dar una idea sobre clase. Y bueno, siempre estamos disponibles, Héctor y yo, para organizar llamadas por Zoom en forma individual o con sus papás para darles más información. Que ahora, bueno, tenemos poco tiempo, nosotros no podemos ir en muchos detalles, pero les aliento a contactarnos y a escuchar la presentación de Héctor a las 5.
Exactamente, sí, muchísimas gracias, Pierre. Vamos a tener entonces a Héctor a las 5 de la tarde, que nos va a platicar un poquito más general de la universidad, como menciona Pierre. Información también para que sepan cómo llegar a Lakehead University. Entonces, muchas gracias, Pierre, por el tiempo y por la presentación.
Un gusto, como siempre. Hasta luego.
Hasta luego.